Welcome to Real AI Now, a podcast about the real applications of AI in business, brought to you by TwoImpulse. My name is Marc Giombetti and I'm a product manager at TwoImpulse, and today I'm your host on this podcast. This episode is going to be about document automation with AI, about opportunities and current trends. Before I introduce our guest, I would like to ask you to subscribe to this podcast. You will find us on YouTube, Spotify, Apple Podcasts, and also on the Google Podcast platform. The links are in the video description below. And if you like this episode, also hit with a like. Today, we have a very special guest, Benjamin von Ardenne. He's currently aiming to unlock human talent by automating highly repetitive processes of complex documents using state-of-the-art AI. To do that, he co-founded lector.ai and has been its CEO since 2020. Before this, he was a software developer at a Swiss fintech and developed different apps in the healthcare industry. He has a background in physics, holds a master's in physics, and also a PhD in Computational and Theoretical Biophysics from Max Planck Institute in Göttingen. And I'm very happy to have him here. So welcome, Benjamin.
Thank you for having me, Mark.
Hi. So let's get started. What is document automation and why is that important?
Okay, let's dive right into it. So document automation is referring to the process of automating the understanding of all the documents that usually arrive at a company. So we are talking about a process where big companies like insurances receive thousands and thousands of documents per day with various content, and they have to process it somehow. And their processes have risen over time, and eventually they have a lot of things that they usually do. And there are a lot of people working on processing these documents. So these are letters, for example, but also emails and many other input channels that now came on top of that. And the fact is that in reality, these companies employ a lot of people who do a lot of repetitive tasks on these documents. Mm-hmm. So like opening the documents, then scanning them. Yeah, it's a little bit hard to get rid of, but then reading through all the documents, understanding what customers have sent in, what they want, and then in more detail, if they want to change addresses or get some money back, all these follow-up processes that need a lot of information from these documents. And right now, in a lot of companies, this is a very tedious, repetitive manual task. And this is what we are focusing on. This is where AI comes in, and this is where it becomes interesting because AI creates a lot of leverage for automation.
Okay. So that sounds interesting. So what you're saying is that there is this huge volume of transaction of paper arriving at these companies, and somebody needs to manually all the time do the same thing. And this is exactly where solution like lector.ai kick in.
Exactly. Yeah. So I think at many companies, it's a legacy thing where all the communication with customers has grown over the last 20, 30 years. Mm-hmm. A lot of like new processes were onboarded that were onboarded before digitization really took foot in these companies, and there are a lot of forms that people have to fill out, often by hand, and that they then send into their insurance. Yeah, mm-hmm. And then the manual work begins right now usually.
Yeah. So as this podcast is about AI, I'm very curious about the particular AI methods being used, right? Because let's say form processing has been around for, I don't know, a decade at least. What has changed and what do these novel methods bring to the table, which wasn't there 10 years ago?
Yeah. So you're right. Scanning a document and digitizing that has been done for 30 years now, or even probably longer. And then a form is usually something where there are some lines, some people write something in it, maybe also print something in it, maybe there are some checkboxes. And if you print the form out correctly, then it looks the same every time you send that in. There were very targeted methods to read out these forms in the past. And it began with non-AI stuff, more rule-based stuff, where people said that in the lower right, there's a checkbox, and I can come up with a rule to describe if a checkbox is ticked on or off. And I can automate this task because we humans also look into this square and see if there's some, ink in there or not. And you can write down a rule, you can put that into code and software, and you can automate this. This is, really nice. And I think like 10 years ago or 20 years ago, this is where most of the value was created. So smart people coming in, knowing how to program, knowing how to automate stuff. Then you have some text, maybe also on these forms, and then people back even in the 70s already developed quite nice OCR, optical character recognition methods to read out text from these things. And you can also plug in these OCR components and then eventually also read out what's written in these forms on certain lines. So you can further drive the readout. And then, you have some handwriting, and you realize that most OCR components have problems with handwriting. And this is where I think the first real push of AI then came in like 10 years ago, where all these deep neural networks then suddenly started to learn handwriting really well. And there are like now standard data sets to train AI models and to also benchmark AI models. And people realize that if you use a neural network to analyze the handwritten stuff, you can read it out better than most of the OCR methods that were in place at that time. So that was the first threshold where people realized, AI can be really helpful in this process.
Okay. So what I understand on OCR, what has changed is like in the 70s, there were like, I don't know, certain rules within the OCR also to basically transform this handwritten content into characters and numbers. But that was very tedious. And now with the AI methods, right, these models were trained on a lot of samples, also allowing the systems to kind of understand the way people write or like the specialities in language.
Yeah. So maybe when we talk about AI, it's always important to emphasize that AI is the removal of explicit rules that I put into a system. And I substitute it by training data, and I let the AI learn the features of a problem itself. And the way you do is you create huge data sets with a lot of, for example, handwritten samples, and you feed it to the AI, tell the AI, this is what you see, this is what is actually written there, and now try to learn to detect all the letters in their handwritten form, and maybe also detect different handwriting styles. And this is how you train the model, and then you have a really good handwriting recognizer that you can now plug in. And that's already quite helpful for things like forms, where the structure is clear and you know where the handwriting usually is, and the problem boils down to really deciphering what a customer has written in a certain field.
Okay. So let's move on a bit on the process. So basically the document get OCR, the text is available. Now I want to do, let's say, extraction. So identify who's the beneficiary or what was the date, or maybe like break down a table into elements. I could do that with rules, but speaking to many clients, I mean, like they are drowning in rules, right? Drowning in extraction rules, and it's just a burden to manage all this. Can you say a couple of words from your experience? Why you think that approach does not work or does not scale, and that AI is like the help to this?
Yeah. So rules have the problem that somebody needs to formulate them first in the mind, and then translate it into machine understandable things like source code or a program. And as you said, the more complex your data input becomes, the more complex the rules become that you need to apply in order to filter out what you really want. And there you need more like smart people who know programming, coding, and so on, that maintain that stuff. And even then, these people start to struggle because the rules pile up and there are way too many rules. And you have to also maintain the rules, even if the data changes, and you have to find out which part of the rules change now, and so on.
Conflicting rules.
and then there are suddenly conflicting rules and so on. It becomes quite it becomes a problem on its own. And usually when we come into projects, there is a legacy system with a lot of rules and implicit rules and business logic there that people are totally exhausted by, and they want to replace. And the AI, as I mentioned before, is then plugged in, and the rules is basically thrown away, and we let the AI learn these rules itself. And it usually turns out that the AI can learn far better than humans can formulate, because the AI usually learns higher order correlations and stuff like that are hard to formulate. So the AI eventually surpasses the quality usually of what humans do or what humans can put into rules in very complex setups. In easy setups, there's this sweet spot where I would say a rule-based system might still be beneficial, because I can write it down easier than the machine, or the cost that I would have to create a machine learning system. Yeah. So if you now go back to the form example, you have all the OCR stuff. There, information extraction is very simple, because a form is already structured in a way that the name is always also prefaced with the label name, and the name is always filled into that box, and then also the birth date is also filled in there. It becomes a little bit more interesting if you go to semi-structured documents, which are also very common to people, like invoices, for example, where it's not so trivial anymore, even based on an OCR version of the invoice, to determine what pieces of text are now important for me to further process, for example, this invoice, and what not. And there we come back to the rules. What people actually started doing based on Abby and some like all these input management tools, they started to do the rules based on this OCR text, and maybe said, for example, an invoice, if I want to know the invoice date, it should be somehow labeled as date or invoice date or something related to dates. And whenever I find some text around it, and I find a text close to that looks like a date, then it's probably what I want to read out. So, and then comes all these follow-up problems. What is a date? There are different date formats, and you pile up all different versions of dates that you see in your data, and then comes another date that you've not seen before, but it also makes sense. So you add it to your rule and so on, and then you drown again this zoo of rules. And what happens in the AI part is you just show the AI in one approach, in which snippet of these OCR invoices you would select for the invoice. So which text represents the invoice date, and which text represents the invoice number, and so on. And the AI itself learns now to connect all the dots together and find the even with a new invoice that it has never seen before, based on the OCR version, to find the invoice number with high confidence.
Okay, so what would you recommend to, I don't know, an operating officer of a company who has this problem that documents are piling up, that these forms arrive more quickly than their internal teams can process? What do you need to kickstart such an initiative of automating document processing?
I mean, the first thing that we usually do is we talk to customers and look at the data itself. And based on the data, you decide which approach to take. So for a form, it might be a different approach than for a very complex handwritten problem, like people in the manufacturing company doing some notes on a sheet of paper to mark progress of a like assembly line or something like that. So different data, different inputs also demand different AI things. So that's always the first thing to really understand the problem. What usually happens is a lot of machine written stuff, like printed stuff, where the OCR is usually not the problem. And then it's usually the decision between structured and non-structured. So structured like forms, or semi-structured like invoices, or non-structured like just like a float text where people
free
say,
text kind of.
yeah, free text. Hello, insurance. My name is. I want to change my my IBAN number or something like that. And this also arrives quite often, and you might want to also handle that. So, and there the approaches become really diverse, actually.
Okay. One thing I want to point out, so basically, okay, it's clear now the way how you would introduce that, right? I'm also quite curious about how do you ensure that the data security and privacy, because these documents, they do contain sensitive information, right? Maybe medical records or invoices from doctors or the like. How do you ensure that the data processing is secure end to end? And also, where does AI help in ensuring exactly that?
Mm-hmm. So, I mean, the easiest way to ensure data privacy is to never let it leave like a data processing center. Mm-hmm. So a lot of customers who are really aware of data protection operate solutions like this on premise.
All right.
So in their data centers, but it comes with its own set of challenges because they now have to become really prolific in operating not just CPUs and memory and storage solutions, but also GPUs. And maybe operating, if you're a big insurance company doing really serious AI, you have to operate basically a GPU cluster yourself. Mm-hmm. to bring down the processing times. So if you have all that, then basically you can silo this processing inside the data center, and then obviously that's the highest protection. So, but then data protection is a very general thing, not just specific to AI, and all the general data protection properties apply also in our field, like high encryption standards and so on. So in the communication, and I think data protection for us is usually comes up in two topics. One is in the model quality. When you train a model for a customer, the customer only has a limited amount of data available, and usually you as a company can improve the quality of the model output by adding more data. Okay. And more data might come from multiple sources, multiple companies. So then you start to train your model with data from multiple companies, and then you might have the problem, if you're not aware of this, that during this whole process, your model spits out information from customer A to customer B, mm-hmm. because your model somehow leaks data, and you have to be absolutely aware of that. So a simple example is like an OCR AI model that might start to hallucinate if I give it just a noisy, like a patch with noise. Mm-hmm. Then it might just output you a random string, but this random string could be, if it's trained on a lot of handwriting of customer A, it might then recognize the name of some of their customers randomly.
And spit that out, yeah.
And spit this out to customer B. So this is something that you want to avoid, and there are a lot of like approaches to do that. I mean, it also has to do with thresholding and clearly filtering out when the AI is not certain enough and so on. But you have to be aware that this is now a new set of data protection problems that you have with AI models if you start to share one AI model with different customers. And the way we usually do is we train very specific models for very specific customers to ensure exactly this, that the data mm-hmm. doesn't leak.
Okay, so you start off maybe with an industry agnostic model, then you build up an industry specific one, and then the peak is really like your client specific one, which is tailored down to the use case you are at.
Yes. So what you mentioned is the whole process of fine tuning, mm-hmm. which is a very interesting aspect of AI itself that you also see, for example, with ChatGPT. I mean, you always have to mention that when you talk about AI these days. Mm-hmm. There are really general models that are trained on basically everything, all the data, or very, very that's general data. But then you can always take this model, or a model is just a set of weights inside these neural networks, and you can take them as a starting point and then say, okay, now I want to fine tune that to the domain of my customer or the domain of the problem. So you could fine tune ChatGPT further to make it a really good, doctor. I mean, it already has really good knowledge of medicine, but like a really good doctor in your area, or you can make an expert in your city and make an expert tourist guide and so on, because you further feed it with a lot of specific data and fine tune on that. But the training to do this fine tuning is not so expensive and extensive as if you would start from zero, because this is usually, I think this is where the journey goes also towards all these things, like general models, as you said, pre-trained with a lot of data, general knowledge, a lot of computing power went in there, and then further fine-tuning it on customer problems.
So if just basically to summarize this for our listeners, so you don't need to be afraid that you need to retrain your company specific model from scratch, but you can build on top of existing models and then just kind of like customize your specifics and just pay also the compute for that.
Yeah, exactly. Yeah. But you have to be careful, because there is only so not every model can be pre-trained. We cannot bring a pre-trained model for every problem. So there are things like invoices or shipping papers and so on. They are so widely used everywhere. Everybody has the same understanding of what these documents have in terms of information. Everybody can read it out. If you give it to a human, he can figure it out. So there it makes sense. But then for some use cases, the thing that you would read out and how you would read it out is so different from customer to customer that maybe the readout model for one customer is not correct for the other customer, because he would read it out differently, because implicitly in the readouts, although it should be as neutral as possible, there is some very customer specific logic in it. So basically the rule tree that you would write down looks different for this customer. And there it becomes problematic to come with a pre-trained model and give it to the customer, because it would not solve the problem of the customer.
I see, yeah.
And there are two flavors, and it's really difficult always to say if it's one or the other. But I think the rule of thumb is, if it's a general type that you and I would understand without much pre-knowledge, then it's more the pre-trained thing would work. And this is also where a lot of the standard approaches from the industry are moving towards, like out-of-the-box standard models for a lot of things that save, that could solve like the 70% case of most companies. And then there are these 30% where you really have to explain what is this form, or what is this document saying, what would it give you in terms of information and so on.
Yeah. So AI nowadays for companies is really accessible, right? You mentioned the 70% which kind of come out of the box. So that's like the thing everybody can start from scratch. Then obviously specifics require more customizing, more tailoring. And that's really like, well, unlimited, right? You can go until the last detail and automate the last bit of it.
Yeah, right.
I was curious. You mentioned ChatGPT, which is more in the generative space of document automation, right? So like generating documents. We also already spoke a lot about the processing of document as such, with extraction and triage and classification. What are the trends you see in this domain? What is AI doing? What's happening next?
Okay. A couple of things. So first of all, we see that the large language models perform really well. And I mean, there's this whole discussion going on if they already have a really, really good understanding of the world just by being trained on text data. And what we are also actively trying to find out is if such a system would already fulfill most of the document understanding requirements. So if it would be enough to just feed ChatGPT, like a chatbot with a lot of domain knowledge about the world coming from text, feed it text, and then ask ChatGPT, please give me the invoice date, please give me the invoice positions, and so on, and let these large language models process, because they've shown such a success lately.
So you would load kind of like the knowledge of that invoice into the large language model, and then you would query the language model again, asking for.
You use the pre-trained, so all this context and general knowledge that the ChatGPT got from training on such a huge data, all this knowledge that we also as humans have. We know what an invoice is. We have all this context knowledge. These large language models also have, and use this to help the understanding. So this is definitely one area where there will be a lot of exploration. But I think there's a second movement that goes parallel to that, but it emphasizes more the visual component, where we also see the release of GPT-4, which is upcoming, and where they now incorporate visual information in the model and make it multimodal. So it's not just a large language model. It can also operate on images, which we as humans also do. So we don't have just an understanding of the world in form of text, but also in form of images and so on. And if you look at a document and the way we humans process it, the visual component is not unimportant. And these approaches that we've talked right now, they have more or less a two-step method. First, you OCR. So you project down your whole document into a linear text stream, and then you do all the AI processing on this text, because you have all these great language models and maybe knowledge graphs and so on. And this turned out to work already quite well. But what is lost is the two-dimensional structure of the document.
So the places where is what.
The places where it's what, and also the relative placing of label to text and so on. And it's 2D versus 1D actually. And
so computer vision versus text processing.
Exactly. And I think the full solution will incorporate the visual component as well. So the final AI that really does the job like arbitrarily better than a human with not much training will be a visual AI. So it gets the whole document pixel-based as an input, and then internally does OCR, internally does maybe also translating the whole thing to text. But then, spitting out what you want to have also in text form, but the input is visual. And I think that's pretty clear that we are moving towards that, and it will get rid of this OCR step, and it will get rid of a lot of the discussions we had in the past with OCR quality and so on. It's all eaten up by AI, which is usually the case. And I think Elon Musk also famously said that, I mean, AI is eating up everything, and end-to-end AI systems are always better than like multi-step, finely grained AI models. And I think that's where we are converging towards.
Okay. So isn't then the, let's say you mentioned basically these document automation platforms, they, exist because there is all this paper, there is all this document. Now in a far future, isn't there the vision that a lot of this processing happens without the physical medium in between, without the paper? So that as these tools get better and better, they are making themselves kind of like redundant in the long run?
In the long run, yeah. I mean, as a CEO of a company that basically helps to automate that, I hope that most of our communication will become standardized by APIs, and there's no paper in between and so on. And there are like now in Germany, like these digital invoices, digital recipes, and all. Right? So there are a lot of initiatives, but at the same time, we see, and this is now heuristic, the number of paper that insurances receive and so on also goes up. So there seems to be a mechanism where companies become more complex, the processes become more complex, and if there's no strict governing against it, people start to create all these processes like another form here, another, like send me an email here, or make this. It's so easy to now contact insurance and so on. So I think more processes come in, and we will never have a constant equilibrium where everything is, the communication between customer and the invoice is highly structured.
Okay. So as a physicist, entropy is going up like usual.
Entropy is going up for sure. So that's why I'm not fearing that too much. I'm more fighting against entropy, and I'm myself a fan of like making everything digital and also standardizing all the communication. But I see at the same time from the way parents, grandparents, and so on communicate, and also us sometimes, it will never be perfectly structured. Yeah. And even if you solve it for one thing, other problems come up that are not like fully solved with a 10-year digitization project that has the perfect API and so on. So people want to move fast, and maybe the fastest answer is to just put a form online and say, just send me in the form. And then, over time, these processes blow up, and then you have another more or less,
I think it's also like, right, the way how companies get successful, right? Maybe, okay, they're starting quick and dirty, right? Let's just put out one form and this is our way of doing it. Or let's just put together a small Excel. And then as they get overwhelmed by success, things grow, then you have this kind of legacy you kind of need to deal with. And that's probably not going to go away.
And I mean, going away maybe from the really physical paper, what we see more is now email as an input channel that substitutes the physical paper. But there, what usually happens is a scan of a form or a photo of a form, or maybe just the whole information, the whole application is now put into the email body. And it's text and so on, but I still have to understand the intent, and I still have to pull out certain information from this flow text. And I still have to have this cognitive challenge of extracting information from a non-structured source. And usually then some people from the insurance do it. But as there are so many emails, it doesn't scale. And then you come back to a solution like this.
Okay. So let's say I have such a solution in place, right? There is the concept or the philosophy of ML ops, machine learning operations. Can you explain to our listeners, what is this all about, and why do I need to do something over the course of time so that my solution stays, let's say, up to date?
Okay. ML ops, machine learning operation, is, I think, a really hot upcoming topic that I talk to customers more and more lately. And I think it comes from this development that AI becomes more and more a commodity. So people expect that there is some AI somewhere, and some processes within a company, some problems are solved by AI. And there are more people around who can train a PyTorch model, pull up a Jupyter notebook, to write some Python code and whatever to train an AI. But just training an AI model on your machine doesn't scale. So eventually you want to put that into a productive process, and you maybe want to update your model, and you want to track how well your model performs, and then maybe later retrain it on more data to make the model better, and so on. And then you want to have a central storage for all your AI models, which can get quite big, a couple of gigabytes. And then, all these models, in order to really feed them data and get some output. This whole process is called inference. And
now we're drowning in models and not in rules, but
we're drowning in models. It becomes more and more complex. More and more people want to do AI, also want to do AI inference. And we have all now these, so companies start to buy all these GPUs, which are really expensive. And they start to have multiple teams now who want to work on AI. And suddenly you have the same problem that probably the companies had 10 years ago, when they had a lot of developers who could now containerize their workload and deploy them themselves. And you as a company now were asked to provide a substrate to deploy everything, all these web services, and the deployment becomes a commodity. And this is where things like Docker and Kubernetes came in. And now the same thing happens in AI. All these AI engineers have all these crazy solutions, but they want to train, they want access to resources. The company wants to manage these resources, access, and so on. And they want to streamline the process. So there is a whole process behind machine learning operations. And just like there's a process of DevOps and so. And I think what will happen is that companies will provide more of these ML ops platforms or features to their employees so that they can do a higher level work, higher level impact. So really train an AI model and really do some impact.
So empowering more and more people, removing the boundary of, let's say, the entry level of training your own model, and also making sure that somebody runs this model for you in a safe environment. And
that you have access to like really valuable resources, the GPUs, which can now these days, like a double A100 from NVIDIA costs like 50,000-60,000 euros. And if you have something like that lying around, and you have multiple teams asking for access to this thing, then you are wondering what would be a good policy to share the resources and manage that. And then you ask, what do you need? What do you need? And they all come up with a similar workflow. And then you realize, okay, there's a common machine learning operations workflow behind that. And it can be assisted by certain tools, platforms, and so on. And I think what you see everywhere is all the companies, I mean, Google, Microsoft, for sure, they've been in the game much longer, but also now companies that have not done AI before are starting to think about, do I need an MLOps platform for my developers? Should I let my AI engineers operate it, or should the SysOps guys that are also already deploying the Kubernetes cluster for me also deploy that and manage that, so that my AI engineers can focus on the actual model training and so.
Okay. So that's really this aspect of operating these models. Maybe you can say a couple of words more about like platforms like, for instance, Hugging Face, which have more the open source spirit of models, which you can then extend. Why is that also relevant in this domain?
I mean, Hugging Face commoditizes this playing around with AIs, making a lot of things open source. So you can read into the latest AI models, approaches, try them out, play around with them. So that helps you a lot. Also from an AI engineer perspective, if you want to determine which model do I use now to solve this problem here. And it's just a nice playground and a nice like first stop that you go to and see what is available right now, what is the state of the art. Because that becomes more and more of a problem now, with so many models being released, so much going on right now. You tend to lose the overview. You know what was the thing in the past with SourceForge and all these open source platforms that are now eventually substituted by GitHub. And I would say most of the stuff is now at GitHub. The same thing, all the same ecosystem, software ecosystem now pops up in the AI community. It's called different and it fulfills some other constraints. But Hugging Face, for example, does the centralized models, centralized maybe also training data.
So it's just the evolution of AI as we saw it in software development with open source. Now also these models are being made accessible, made, let's say, easy to use.
Yeah,
and the integration applications will just be quicker.
Yeah, totally see that. And I mean, the fear is always that AI is blocked away at some companies that only them know how to use it. But we see the opposite movement right now. It's there's a lot of work in terms of open sourcing approaches, making it accessible and making it accessible to everyone. And I think where it will go is it will become a commodity, just like Web 2.0, like everybody can run a website where people can post something and so on. It's the same with AI. Everybody will eventually operate some part of AI and interact with an AI. And I guess 90% will just use an AI, then 9% will maybe train an AI, and 1% will actually know how it works. So this 99.1% thing, just the same like the internet operates. 90% read, 9% maybe comment, and 1% create.
So it's really this kind of like it gets more scalable, it gets bigger, more people can profit from it, and AI will just become like kind of transparent, the normal thing.
Yeah, part of what you would take for granted. So really a commodity like water and electric power.
Electricity,
Yeah. Okay. So, but it will be a long way to make this a commodity, because a lot of standardization things still have to happen, and they happen interestingly exactly the way they happened with the internet. So really chaotically. So some big companies driving that, and you always have to be careful that not a few players dictate this standardization process too much. Like, we see.
Or it's called open.
It
has open in the name, but isn't open.
Exactly. Yeah. So
okay. Well, I like that thought of having like electricity, water, gas, internet, and AI being kind of like your basic supplies to strive in the modern world.
Yeah. I like this too. I mean, I want to. I mean, ChatGPT, for example, became more or less a commodity overnight. It's quite fascinating how everybody can spin that up and everybody can ask questions. It's open and everybody can use it. I mean, I think that the time from it being public to being a commodity is the shortest I've ever seen with any technology, and I think this is recognized a lot. Now, question is how more AI approaches become like standard and a commodity, and this is one of the things that we want to drive. Eventually, I see. So right now, we're doing a lot of also custom things like exploring data sets, exploring the ideas for a customer, making everything tailored to one customer. But everything spins out more and more into standard products, and then even more into things that you take for granted, and you don't even think that it's complicated anymore. Or why should I pay for that? Everybody has that. We are not at that stage, but we will reach that point.
Yeah. So I think, and that's also partly where the Just.ai group, which lector.ai is part of, right, and Twimpulse also partnering up, right, bringing this kind of innovation to clients in a sustainable way, so that they can just run and operate this on their own, generating, let's say, continuous value, right?
Exactly. You cannot. So right now, I see always this need. We want to do something, but I don't have the people. So I mean, we usually help the people to incorporate some AI into their process. Yeah, and we also consult them. Do I need an ML ops platform myself? Should I host it, or should I buy that somewhere in the cloud, and so on? How does it work with data protection, and so on? Yeah.
Okay. Well, that was a great discussion. So thanks, Benjamin, for your insights on this very interesting topic. And thanks for joining me today on the Real AI Now podcast.
Awesome. Thanks, Mark, for having me.
Yeah. So to our listeners and viewers, I would also like to remind you that this episode is available on Spotify, Google Podcasts, and Apple Podcasts. And please give us a like and subscribe to the channel. And then thanks again to listeners. Thank you, Benjamin, and wish you a good day.
Bye.
Bye-bye.